Page 122 of your student journal, starting chapter 5. Chapter 5 is solving systems of linear equations. So this whole year so far, or throughout this whole course, we've been figuring out lines, and systems are just multiple lines. So as long as you know how to figure out lines, now we're just going to be looking at multiple lines in one problem or one graph. So we're just going to head on down over here. Core concepts. Solving a system of linear equations by graphing. Graph each equation in the same coordinate plane, estimate the point of intersection, and check the point from step 2 by substituting for x and y in each equation of the original system. So as an example, I'm going to come up with two equations. One is y equals x plus 2, and the other one is y equals 2x. So you can graph these by finding the x and y intercepts for both of them and then connecting the dots, or plugging in a series of points, a series of inputs to get the outputs, whatever you choose to do. For the sake of the lesson, I have this handy dandy graphing calculator from Desmos, and I'm going to type in these two equations, and I'm going to estimate the point of intersection. So first I'm going to graph it using this graphing calculator, and then I'll estimate the point of intersection. The point of intersection is where they are connecting or touching. So here the one in red is x plus 2. So if x is 0, I add 2, I get 2. So 0 and 2, that makes sense. 1 and 3 is another point, because if you start at 1 and you add 2, you get 3. 2 and 4 also makes sense. Here, the second line is 2x. So that just means 2 times whatever number you use for your input. 2 times 0 is 0. 2 times negative 2 is negative 4. 2 times negative 4 is negative 8, and so on and so forth. But it says here we should estimate the point of intersection, which is where they connect. This looks like 2, 4. It looks like they are both touching at 2, 4. So let's check by substituting for x and y. So 2, 4 means I'm plugging in 2 for x and expecting to get 4 for y. So let's see. 4, because that's my y. Let's see here. Y and x. So 4 equals 2 plus 2. Is 4 equal to 2 plus 2? Yes, that makes sense. I have 4 equals 2 times 2. Is 4 equal to 2 times 2? Yes, that also makes sense. So when we have a solution or an answer, it must work for not just one of these equations, but for both. So in this case, we check the point, it works out. 2, 4 is the solution for this system of equations. I can clear this, and we can move on to the next. So tell whether the ordered pair is a solution of the system. So we're going to do exactly what I just showed you guys, is to substitute and check. So let's see here. This is our x. This is our y. So 3 plus 1, 3 plus 1 equals 4. Boom, and we're finished. But if it works for one, I could just stop, right? Wrong. The solution has to work for not just one, but both equations. So let's check it out for the second one. 2 times x, which is 3, minus 1 equals 3. So I got 6 minus 1 equals 3. Is that right? 6 minus 1 is equal to 3? Wrong. 5 is not equal to 3. So if it works for one, but it doesn't work for the other one, is that a solution? The answer is no. The ordered pair is not a solution. And then you just go through that for the rest of these. All these, I'll write out a few. 1 minus 3 equals negative 2. Again, this is just x, this is y. We're just replacing, we're just substituting and seeing if it checks out or not. So negative 2 equals negative 2, that checks out. 2 times 1 plus 3 equals 5. 2 times 1 is 2. 2 plus 3 is equal to 5. Yes, that's true. So this one, for this problem, yes, the ordered pair is a solution. And one more time, just anywhere you see y, you will replace it with a 0. And anywhere you see x, you will replace it with a 2. So 0 equals 2 minus 2. Or 0 equals negative 3 times 0. Sorry. Times 2 plus 6. And then you guys verify in your calculators. Yeah, that's it for all these. Just substitute and check. Use the graph to solve the system of linear equations. So again, the solution solve and solution. That means point of intersection. So I'm just gonna circle them each. Well, I'll circle it for the first two, so you guys. Whatever. We got 2, negative 2. 2, negative 2. And when it says check, that means you're going to do the same thing you did in the whole last section, where you say this is your x, this is your y, and you substitute in both equations, this one and that one. 3 times 2 minus 2 times negative 2. I'll just do that just to make sure. 3 times 2 minus 2 times negative 2 equals 10. So I have 6. You could say 2 times negative 2 is negative 4. Or you could just say, so I would say subtract negative 4. Or you could say negative 2 times negative 2 is positive 4. Either way makes sense. Or you could say 6 minus negative 4 equals 10. It's entirely up to you. You're going to do the same thing. 6 plus 4 is 10, so that's right. 2 plus negative 2 is equal to 0, and 2 minus 2 is 0, so we're good. That's a solution. Here, the solution you'll be checking is negative 1. Let's see, negative 1, negative 1, 2, 3. So you guys have to check that solution to show your work. This solution is 4, 2. Again, check your solution, show your work. Solve the system of linear equations by graphing. The easiest one to me, so I'll do, let's see, I'll do 10 and 14 for you. Again, the easiest way to do this, at least from last time, is to just go for y and x intercepts and connect the dots. So if you forgot what that means, it means plug in 0 for x and y for each equation to see what you get. So for here, I'll take a number 10. So I'll say the y-intercept is when x equals 0. So say y equals negative 0, pretend that's a parentheses, plus 3. Y equals 3. So my y-intercept, after I plug in 0 for x, is 0, 3. So I have a point here, 0, 3. That's my y-intercept. And then my x-intercept is when y equals 0, so I will say x-intercept is when y equals 0. 0 equals negative x plus 3. So I will subtract 3 on both sides. 0 minus 3 is negative 3 equals negative x. I divide both sides by negative 1, and I get 3 equals x. So 0, 3, and 3, 0. And what I'm going to do here to graph this line is to just, you should use your ruler, but I know how this is going to play out, so it looks like that. The slope is negative 1, which means down 1 over 1, which makes it down 1 over 1, down 1 over 1, down 1 over 1. To go backwards, you go up 1 over 1, up 1 over 1, up 1 over 1. Ooh, all that for one graph. We're actually going to go over here now and find the y-intercept is when x is equal to 0. So 0 plus 5 is equal to 5. The x-intercept And if you're not sure how to do this, just go ahead and go back to the last chapter and find the video on finding x and y intercepts. So we get -5 or 0 equals x plus 5. Subtract 5 on both sides, you get -5. So for this one, I get 0, 5, and in fact, I will change the color. Let's see, let's go with red. Okay. So you have 0, 4, 5. We have -5, 0. Ooh. Ooh. Excuse me. So we have this guy right here. Okay, so what does it look like? The point of intersection is -1, +4. -1, +4. -1, that's a negative sign. And that's it. So you approach all these problems the same way, plug in 0 for each one, and then just go for it. Let's see, I'll do number 14 next. That's fractions, but again, like this class is not meant to teach you fractions, so if it's hard, just do your best and try and slowly pick up fractions over the course of the year. So I'm just gonna tell you guys the intercepts. So the intercepts for this one, when x is equal, this will be the red one, and I'll make the next one blue. 0 plus 3, and then the other one, y has to be 0, so that has to be -3. Has to be, let's see, what times divided by 4 will give you -3, -12. What? It doesn't even give you space to graph this. Okay, well, I'll figure it out. This one would be 0, 5. And, oh boy, this is awkward. Okay, so we're actually just going to start, or here's another method. We're actually just going to use the y-intercepts and then use the slopes. So what do I mean by that? Let's start off with the red first. So our y-intercept is 0, 3. And this is rise over run, right? Rise, rising by 1, run, running by 4. So I'm actually going to go up 1 and over 4. 1, 2, 3, 4. And to go backwards, I'm going to go down 1 and to the left 4. 1, 2, 3, 4. So that's that. Okay. And then this blue line right here, which I'm going to make blue. So I have 0, 5. And my slope here is up 3 and over 4. Ugh, so I can't go up because that will just take me out over here. So I will actually go down 3 and to the left 4. So down 1, 2, 3 over 1, 2, 3, 4. Oh, well, would you look at that? So you have this point of intersection right here, which is -4, +2. -4, +2. Again, you guys will use your rulers, make the line look like that. Extend the red line. But your solution will be -4, 2. Okay, so that's it for solving systems by graphing. You can use the slope, you can use the y-intercept, you can use the x and y-intercepts, you can use whatever method you want in graphing to figure out where these lines intersect. The test has 20 questions worth 100 points. The test consists of x true questions, true false questions worth 4 points each, and y multiple choice questions. So let's see. The total, so let's say 4 times x plus 8y equal 100. So there are a huge, wait a second, the test consists of x, oh, the test has 20 questions. X plus y equals 20. So at most, let's see. I'll solve this one first. So x plus. So we could have 20 true false questions and 0 multiple choice. We could also, on the other end, we could also have 0 true false and up to 20 multiple choice. It's not likely that either of those is the case, but again, we have 20 0 and 0 20. So what that looks like is here. Oh, let me just make that line. It looks like that. And then this first equation I will make red. Sorry, this one I will make red. So if I have 4x plus 8y, I could say 25 and 0. And then on the other hand, let's see, what's 100 divided by 8? 100 divided by 8 is 12.5. So I'll say 0, 12.5. Which is going to be around, see, if this is 13, this is like the halfway point. And then we go 25, 0. Oh, which is all the way over there. Another way, okay, fine. Then we'll take another method. So this is good because it's me forcing myself to show you guys how to problem solve in multiple methods. So what I'm actually going to do is this. I'll subtract by 4x. I'll say 8y equals negative 4x plus 100. I will divide by 8. I'll get 8y equals negative 1/2 x plus 12.5. So I start off at 12.5. I will move down 1, which is 11.5, and over 2. So down 1, 11.5, and over 2. Down 1, oh, make the dot. There it is. Down 1 over 2. Down 1 over 2. Down 1 over 2. It looks like it's going to be somewhere around there. So this is a ballpark guess, but it looks like this is going to be our solution. 16 and 4, which makes sense because 16 plus 4 is 20 questions. And let's see if they add up to 100 points. So if I have 16 true-false questions worth 4 points, 16 times 4, or 4 times 16 from over here. Sorry. Plus 8 times what? 8 times 8. Oh, sorry, 4. I'm going crazy. I knew something was funny. 4 times 8 times 4. 8 times 4. Sorry, I don't know. I'm having a brain fart right now. It must be in the morning. 8 times 4 equals 100. So I have 64 plus 32 equals 100. Oh boy. So this is 96. Is that correct? Is 96 equal to 100? No. So what happened? Let's go over this problem real briefly. 25, 0. Did I multiply correctly? 0, 20, 20, 0. 16, 18, 20, 0, 20. Okay, so I definitely got those right. Double check for x. 25 times 4 is 100. So at 25, 0. 8 times 12.5 is 100. So these two are correct. 4 divided by 8 is negative 1/2. 12.5. Maybe my line is just a little off by drawing it. Let's see, 16, 4 times 16, and then 8 times 4. Yeah, that's not good. It's very close, but it's not quite right. So I think if I'm only off by 4, what is it? It's either going to be 17 and 3, And this is like just me ballparking it now. So I have 17, 3, or march it back 1, 15, and 5. So again, let's just run our guess and check with this. So 4 times 15 is 60, plus 8 times 5, and this one looks like our winner. 60 plus 40. Yep. So the answer is 15 15 true false and 5 multiple choice. Why did it come out screwed up on my graph? Honestly, it's because if you notice, 12.5 is supposed to be right there. I angled my graph wrong and it came out screwed up. But I'm sure you guys are better than graphing at me, so this is your solution, 15.5. When you graph, make sure you do it carefully. Otherwise, you'll see that you make mistakes like I did and you get screwed up. But again, for the sake of the lesson and the context of like you knowing how to graph, it's not a big deal for me to make that mistake. And it's good for you guys to see that, yes, even when I'm making a lesson, I make mistakes too. So hopefully you understand how to graph, plugging things in, checking points of intersection. And if not, ask your teacher or let me know. Good luck.